Hello guys, welcome back. This will be part 1 of our exercises here for section 1 of chapter 1 here in our Algebra 2 full course. So let's go ahead and take a look at some problems. We won't cover every problem. So this will be a multi-part run through of our exercise set here for section 1 in chapter 1. All right, so our first problem here, number 1, is a vocabulary question. Braces are used in interval notation or roster notation. So let's think about the two notation types here and which one uses braces. In interval notation, for example, which symbols do we use for the endpoints? We're either using brackets or parentheses, depending on if it's included or excluded, the integer. So which notation uses braces? It would have to be roster notation. All right, roster notation uses our braces. And we also talked about set builder notation, which we'll get to soon, where we have our X and a slash and an inequality symbol and such. But this first question was asking us between interval notation and roster notation. Braces are used in roster notation. All right, let's go to our next part. We're going to order these numbers from least to greatest here for 2, 3, and 4. Then we'll classify each number by the subsets of the real numbers to which it belongs. So let's take a look here at number 2. First, we want to convert to decimals. So for example, 3 square roots of 2, we can just multiply 3 times the square root of 2 in our calculator. This will give us 1.414, which comes out to 4.243. And the square root of 7, if we punch that into our calculator, we'll get 2.646. 5.125 is already in decimal form. 4 3/5 will get us to 4.600. And then with our decimal, with the repeating bar over, it just means that it's going to go on forever, which I'll use the ellipsis there to represent that. So always convert everything to a decimal first when we are ordering from least to greatest or greatest to least, for example, and then we'll treat each number one at a time. So which two numbers, for example, are closest to each other, and how do we know which is larger? So we have 4 3/5 is 4.600, and 4.6 with the repeating bar over is 4.666, on and on forever. So 4.6 will be larger because, for example, 0.666 would be bigger than 0.600. 666 would be bigger than 600, right? So we can start to order here. We have 2.646. Let's go over here where we have more room. Start to order here. We have 2.646. Let's use our inequality symbol. Is less than 4.243. Is less than, now here we want to put 4.600. Is less than 4.666. And then we have a 5. 5.125. All right, now we can go back and remember we want to, in our homework, for example, list the original values that they give. So let's go back and write those to what they correspond to. I'll do that in red. So we'll begin with the square root of 7. Then we had 3 square roots of 2. Then we had 4 and 3/5. And then 4.6 with our repeater bar. And then 5.125. And that's how we do it. Let's take a look at 3. Let's write out our decimals first. Let's begin with negative 100 divided by 4 will be negative 25. And then negative 6.897 is already in decimal form. The square root of 4 is 2. 1/8, if we divide that out, 1 divided by 8 will get to 0.125. And then our square root of 6 will get us to 2.449. All right, let's go over here and write that out in the margin. Let's notice that negative 100 divided by 4 down to negative 25 simplifies to a large negative number. So negative 25 will be our starting point here. We're going from least to greatest. Negative 25 is less than negative 6.897, which is less than 0.125, which is less than 2, which is less than 2.449. Now we'll go write those out like they were originally presented. So we begin with negative 100 divided by 4, 100 fourths, negative 6.897, one-eighth, square root of 4, and square root of 6. All right. There they are from least to greatest. Now let's go to number 4. We'll convert first. Here we have the square root of 5. Let's go ahead and start writing out our decimal places here. For the square root of 5, we'll have around 2.236, approximately. For our pi divided by 2, we'll get approximately 1.571. Just remember pi is 3.14159 to help you remember that easily. 14159, right? And we divided that by 2 and we get to 1.571. All right, now we have our first negative value. We have negative square root of 3, so let's go ahead and write that with a negative value. That will be negative 1.732. And we have our repeating bar, 1.333 on and on. And we have another negative value. This will get us to negative 1 1/3 will get us to negative 1.333 on and on and on. Now let's write those in order. All right, so 1.3 with a repeating bar, negative 1 1/3, which equals negative 4/3, is going to require careful handling. Their absolute values are the same, but we're looking for which one is larger, which one is smaller, the positive versus the negative here, right? So we'll just be careful with that one. But here we have negative 1.732 is less than negative 1.333 is less than 1.333, negative positive, right? Less than 1.571 is less than 2.236. Now let's go right in those original values. This was the negative square root of 3, negative 1 1/3, 1.3 with the repeating bar over it, pi over 2, and the square root of 5. From least to greatest. All right, that will conclude 1 through 4 there, or 2 through 4 for the first section where we're ordering, given numbers from least to greatest. Okay, now we're going to use interval notation to represent each set of numbers here for 5 through 7. All right, so we want to check each endpoint. Negative 10 is excluded. It's strictly less than 10. 10 is included as less than or equal to. So which bracket are we using at each endpoint? Here we want to use parentheses at negative 10 and a square bracket at positive 10. Open parentheses, negative 10, positive 10, close bracket. All right, so we're going to notice that we have negative 15 infinity in the negative direction, and an open circle here at negative 5. That's where we want to start. So our infinity will always have parentheses, negative, flip that 8 around to get to the infinity symbol there. And then we're going to put a comma. Now negative 5, is it included or not included? Not included. So let's put a parentheses here. It is not included. Now we'll take a look at 7. Here we have it written with our inequality symbols. All right, so we'll take note that 2 separate conditions connected by or means 2 separate intervals. So we'll write the interval for each condition separately. Let's begin with our first one, and we're going to put an or in between. So we have x is greater than or equal to 1, but less than 20. So if it's including 1, we want to put an open bracket for our 1, and it does not include 20. So let's put a closed parenthesis there. Or in the middle, and now we're ready for x is greater than 30. So we will be bringing in our positive infinity here. Now it does not include 30. So let's put an open parentheses there. And then our infinity will always have a parentheses, so closed parentheses. And there's our answer. All right, let's go to our next problem. Section 3 here, 8, 9, and 10. Rewrite each set in the indicated notation. We'll begin with number 8. So let's begin by simplifying the expression on the n side. What is n minus n, for example? And this goes for any value of n. That will be 0. So this becomes x equals 1 plus 1/2 times 0. Now let's write that out. We'll have x equals 1 plus 0, which will equal 1 for every n. Now, since the only value x can take is 1, this is the set containing only 1. So let me put that into words. The set containing only the number 1 which is, let's bring in our brace. Open and close braces there for 1. So let's take note that this problem was testing some careful algebraic simplification inside of set builder notation. So our process here was to simplify the rule before describing the set. All right, let's take a look at our next problem, number 9. Let's label first. So we're using set builder notation here. We have a -5. It is a closed circle, and here we're at +3 with an open circle. So we have all values between -5, inclusive of -5, and 3 exclusive of 3. Let's write that part first. All right, so I'll write all x such that, here we'll bring in our inequality symbol. So let's put x, let's just write -5 first. -5, it does include it. X will be greater than or equal to -5. And it will be less than 3. Do not put the equal to or bar below that one, right? Because it's an open circle. All right, let's get this into correct set builder notation. We'll just put it over here to the right. Let's start with our open brace. X with the bar, that's how we begin our set builder notation. And then we already wrote our inequality out. So let's repeat that one. -5 less than or equal to x less than 3, and then our closed brace. All right. That's how we do it. Or just adjust to match the specific number that's shown on your line. Now, what's helpful is to describe the number line in words first before you write the notation, and then go through the step-by-step process to prevent yourself from guessing. All right, on to number 10. We have a pattern here in our elements. So let's think about what rule connects 0, 5, 10, 15, and 20 together. These are multiples of 5 that start at 0. So let's go ahead and write that in words. The set of non-negative, multiples of 5 or whole number multiples of 5 starting at 0. Whole number multiples of 5 starting at 0. Now that ellipsis there is important. It signals that the set is infinite and continues that same pattern indefinitely, right? All right, we'll take a look at one more here in the set, and we'll call it an end to part 1. Part 2 will begin with number 12 in our practice and problem solving section. Number 11, integers from -5 to 5 in roster notation. Here we'll list every integer from -5 to +5 in order, separated by commas inside braces. Are -5 and 5 included? Yes. The problem says -5 to 5. What about 0? 0 is an integer, so it will be included. So let's count. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. That would be 11 elements, right? Let's go ahead and write that out. Here's our open brace. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and close out the brace. All right, that'll do it for part 1 here in our exercise set. Remember, we're in 1.1, the very first section of chapter 1 here. We just finished 1 through 11. We'll jump into number 12 in the next part. See you soon.